Right, so Year 7, Pre-Test, Module 4, Walking, Talking, Mock. So, question 1. What fraction of the shape is shaded? There's some bold words which are important, otherwise we'd underline them. So we look at the fraction, it's split into 5 equal parts. So that means it's out of 5. And we want the number that are shaded. 1, 2, 3 of them. So there are 3 parts shaded out of 5. So remember, you're copying exactly what I write down as a minimum. But if there's anything you want to write in addition, extra, any notes, then you can write those notes down. Right, question 2 is as a number line. So give as a fraction. So the answer does need to be a fraction. The value of the number the arrow is indicating on the number line below. So we need to look at how many of these there are. 1, 2, 3, 4, 5, 6, 7. There are 7 increments, so the fraction is out of 7 equal parts, and we are 1, 2, 3 along. So that is 3 sevenths. Right. There's 2 marks, it is 2 answers. Which of these show 3/5 shaded? Now remember, you need to have a same area, an equal area. So 3/5. That's split into 5, but only 2 of them are shaded, so it's not A. That looks like it's split into 10, but then we realise that if we look at them as columns, there's 5 columns taken in a rectangle and a square, so they could be fifths, but again, only 2 of them are shaded. This one has 15 blocks, but if we look at them in terms of full columns, it has 3 full columns shaded out of 4, 5. So that has 3/5 shaded. So C is our first possibility. D is a circle split into 1, 2, 3, 4, 5 equal bits and 3 are shaded. So it looks like it's C and D, but it would be silly not to check the last one. That's split into 5 pieces, but they're not equal pieces, so they're not fifths. It can only be fifths or a denominator if it's that amount of equal sized pieces. And on to question 4. Question 4 is 2 marks. What number is represented by this diagram if each full circle represents one whole? Give your answer as a mixed number and an improper fraction. And the screen can't pick this up very well, but they are shaded and they are just not that last one. So a mixed number is a mixture of whole numbers and fractions. So that's one whole one, and it's split into 1, 2, 3, 4, 5, 6. And out of those 6 bits, 5 are shaded. So the mixed number is 1 whole 1 and 5 6. They're both in sixths, so our improper fraction is out of sixths also. But now we count up. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 sixths. So you should have got all that written down exactly as I have. And then we move on to page 4. This is on to part 2. So here, we're comparing and ordering fractions, decimals, and mixed numbers. So it might be that it wants us to give us our answer in a certain way. If it asks for an answer in a fraction and you give it a decimal, obviously you're going to be wrong. I'm going to give you a detention if you don't stay looking at the board. Understood? Change 19 sixths to a mixed number. Now, if you want to do this as a bar model, you can draw a bar and split it into 6 parts. That's 6 sixths. So I'm going to need another bar. That's another 6 sixths. That's 12 sixths. I've got 6 sixths, 12 sixths. So I'm going to have another whole bar. That's 18 sixths. So I'll need one more left over. So 19 sixths. Those are my 19 sixths. I have 1, 2, 3 whole bars. And then 1 6 left over. The way to do this without the bar modelling if you're at that point where you can understand it, is you're looking for how many 6s go into 19. 6 goes into 19 once, 1 whole 1, twice, 2 whole 1s, 3 whole 1s, 3 6s are 18, which means then we've got 1 6 left over. 1 mark. Part B wants you to change a mixed number to an improper fraction, so you're doing the opposite of this. So I've got 2 whole 1s, so that's my whole 1. That's my second whole 1, and we're in fifths this time, so 4 lines makes 5 equal parts. 4 lines makes 5 equal parts, so that's my 1 whole 1, that's my second whole 1, and this time, out of fifths, I only want 1, 2, 3, 4. So how many fifths have I got? I've got 1, 2, 3, 4, 5 in the first whole 1, 6, 7, 8, 9, 10 in the second whole 1, plus those 4 more, I've got 14 fifths. So now it takes you a little bit longer to copy down the bar models, and that's fine. If you're at the point where you can start to understand this without a bar model, if it's in fifths and you've got 2 whole 1s, that's 2 lots of 5, which is 10, plus the 4 fifths left over, which gets you 14 fifths. Right, equivalent was word of the week a couple of weeks ago. We used it a lot in maths, we use it a lot in maths all the time. Equivalent fractions, EQU, is the same as the start of the word equal. So we're looking for 2 fractions that are equal. So we need to see if there's any that we can multiply up to mean the same thing. So that's a small one. We could see if we can multiply that up to anything. If I times the top and bottom by 2, I would get 6 over 10. That won't work. If I times the top and bottom by 3, 3 3s are 9, 3 5s are 15. They are equivalent. 3 fifths is not equivalent to 16 over 20 because 5 would have to times by 4 to get 20, but 3 4s are not 16. So you need to find fractions which are multiples or factors of one another. 9 is a multiple of 3 and 15 is a multiple of 5, and it's the same multiple. In both of them, you times by 3. And it's really important that you do the same to the numerator, the top number, as you do to the bottom number. You should be copying exactly what I'm writing. Question 7. Which one of the following decimals is equivalent to 8 thousandths? Well, if we think of our number columns, which we've done loads of in year 7, you've got your ones, your tenths, your hundredths, and your thousandths. So if we've got 8 thousandths, let's put an 8 in the thousandths column. If the decimal point's there, we're going to have to put some zeros in as place value holders there. So 0.008 is our answer. There were 8 thousandths, so we changed it to 8 in the thousandths column. Just out of interest then, this has an 8 in the hundredths column, so this one would be the same as 8 over 100. This has 8 in the tenths column, so this one would be the same as 8 tenths. And this has an 8 in the ones column, big 8, and then a 1 in the tenths column, 8 and 1/10. So that's them all changed from decimals to fractions.
So, how come you know how to do that the easy way?
Because I'm a brilliant teacher. Okay, give the decimal 0.35 as a fraction. Now, there's 2 marks here. The first mark is just for give 0.35 as a fraction. And if we use the method above, you've got a 3 in the tenths column, but you've got a 5 in the hundredths column. And you can't write 3 tenths and 5 hundredths. So we're going to have to look at all these being as hundredths. So you've got 35 hundredths. That will get you 1 mark if you leave it there, but if you leave it there, you've ignored the second instruction, which is simplest form. And simplest form, if you look on, it's actually my year 8 keywords this term. If you look on my keywords on my never heard the word grid on my washing line, simplest form is up there because they're doing it with ratios as well as fractions. But we're looking for simplest form here, so maybe it should be on our year 7 one next time we do this half term. So, I'm looking for numbers that definitely go into 35 and 100. And given that it ends in 5 and 0, the 5 times table jumps out at me. So 5s into 35 go 7 times. So I've divided by 5. So I divide by 5 on the bottom. And 100 divided by 5 gets 20. I know I can't get any simpler than 7 over 20. And the reason is 7 is a special number. From half term 1, we know 7 is a prime number, so we can't simplify it any further. We couldn't simplify it any further because the factor of 7 is 1, but then we'd have to divide 20 by 1 as well. And if we divide them both by 1, it'll stay as 7/20. Okay, write each number above the corresponding arrow. So, we've got 4 over 4, 2/3, 4/5, and 0.45. The easiest one, we should all know that 4 over 4 is a whole one, 4 divided by 4. So 4 over 4 goes there, and when I use something, I like just to put a neat line through it. I don't scribble it out because I want to be able to see it still, but now I know I've used it. 2/3 and 4/5. They've got different denominators, so whilst they're smaller parts, there's more of them. So I think the sensible thing to do here would be the same as we've done when we've added fractions, Josh, which is to change them to a common denominator. So if I make them both over their lowest common multiple, which is 15, I've had to times the 3 by 5, so I'll have to do 2 5s are 10. This one, though, I've had to times the 5 by 3, so I'll do 4 3s are 12. So that definitely tells me that 2/3 is smaller than 4/5. Now, I can see that both of those are bigger than a half, because a half of 15 is 7.5. And I know 0.45 is smaller than a half. So 0.45 is less than a half, which goes there. And then we've worked out that 2/3 is the next smallest. And 4/5 is the one after that. So that's 8 out of 8 marks for part 2. I just remind you, you need to be writing exactly what I write, but if there's any additional notes you want to add on, for example, we could write there, changed to a common denominator so I could compare them. Anything like that I think is really good practice. Right, we're not far off. Part 3. Now, I'm conscious that some of you, especially because we've had some snow days, have missed a few lessons this half term, so some of you might be only moving on to multiplying and dividing by fractions now. I'm still going to have to go through it as if you've been taught it, but what might happen is you need to revise it, and from the revision and from some of the stuff I've shown you, your lessons at the start of next week are easier as well. So I'll just